Welcome to aminacademy.com. In engineering thermodynamics, let us discuss about pressure and its measurements. Pressure is defined as a force per unit area. Pressure are exerted by gases, vapors and liquids. The instrument that we generally use, however, record pressure as the difference between two pressures. Thus, it is the difference between the pressure exerted by a fluid of interest and the ambient atmospheric pressure. Such device indicates the pressure either above or below that of the atmosphere. We'll discuss further. Pressure is defined as the physical force exerted on an object. Force exerted on an object. The force applied is perpendicular to the surface of object per unit area. The basic formula for pressure equals F over A. Force per unit area. Unit of pressure is Pascal. Now we'll discuss that schematic diagram showing the gauge pressure, vacuum pressure and the absolute pressures here. Look at here. This is a absolute zero, that is complete vacuum. Here first this one is absolute pressure, and from that vacuum pressure, from here to here gauge pressure, this from here to here local atmospheric pressure, totally absolute pressure. Now what is absolute pressure? Absolute pressure is a pressure that is relative to the zero pressure in the empty air-free space of the universe. This reference pressure is ideal or absolute vacuum. Now, atmospheric pressure, the air around you has weight and it passes against everything it touches. That pressure is called atmospheric pressure or air pressure. That means we are staying still in atmospheric pressure level. Atmospheric pressure, that is ATM, is a unit of measurement equal to the average air pressure at sea level at a temperature of 15 degrees Celsius, that is near to 59 Fahrenheit. One atmospheric is 1013 millibars, that is 760 millimeters, and further it is 29.92 inches of mercury. These are the different scale for the atmospheric pressure. Next one, gauge pressure, is the pressure relative to a atmospheric pressure. For the pressure above atmospheric pressure, that is the gauge pressure is positive. For the pressure below atmospheric pressure, is gauge pressure is negative. The pressure gauge is also known as pressure meters or vacuum gauges. Here, for absolute pressure is pressure equal atmospheric pressure plus gauge pressure. Then what is vacuum? Vacuum is any pressure less than the local atmospheric pressure. It is defined as the difference between the local atmospheric pressure and the point of measurement. A vacuum is correctly measured with a differential pressure transducers that has one port open to atmosphere. Therefore, vacuum pressure is P vacuum equal atmospheric pressure P ATM minus absolute pressure. absolute. Here, next is Pascal formula. Pascal is Newton per meter square. That is equal kg per meter second square. Now, this table is the list of unit pressures. It is useful for calculating different stages. That is, look at, for example, 1 Pascal is 1 Newton per meter square. That is in bar is 10 power minus 5 bar, and technical atmosphere is 1.019 in 10 power minus 5. Standard atmospheric is 9.8692 in 10 power minus 6. Torr is 7.5006 in 10 power minus 3, and pounds per square inch is 0.000145 lb foot per inch square. This table of conversion is very useful to calculate different pressures. Now, what is pressure gauge? We will explain the pressure gauge. The devices that are used for measuring pressure are called pressure gauges. Gauge pressure is the pressure relative to atmospheric pressure. For the pressure above atmospheric pressure, gauge pressure is positive. For the pressure below atmospheric pressure, gauge pressure is negative. The pressure gauge is also known as pressure meters or vacuum gauges, a device that uses the surface area and weight of a liquid column to measure and indicate pressure is known as manometers. Most gauge calculate the pressure relative to atmospheric pressure as the 0 point. Hence, this form of reading is known as the gauge pressure. Pressure gauge are analog as well as digital. We know that pressure formula is pressure difference between the system and the atmospheric is given by P equal to PA plus rho GH, where P equal to pressure at any point, PA is atmospheric pressure, and rho GH, we know that rho is density of liquid column, liquid, G is gravity of earth, and H equal to height of liquid column. From that we can find, suppose rho GH you can find by using P minus PA, or we can find PA equal PO minus rho GH. We can find this from this formula, we can get what we need. Types of pressure gauges. Depending on the usability and purpose, whether it is for commercial purpose or industrial purpose, most common pressure gauge are designed. Some of the pressure gauges are board-on tube pressure gauge, diaphragm pressure gauge, capsule pressure gauge, absolute pressure gauge, differential pressure gauge, bellows pressure gauge, manometer pressure gauge, and piezometer pressure gauge. Here, first is board-on tube pressure gauge. A board-on tube is the most commonly used pressure gauge. It is a mechanical instrument that measures the pressure without an electric supply. It's made up of steel to resist wear and corrosion. A board-on tube pressure gauge can measure pressure 0.6 to 7,000 bar. Diaphragm pressure gauge. It is a device used to measure the pressure of fluid in a system. It is purposefully designed to measure low pressure intensities. A diaphragm pressure gauge is also known as membrane pressure gauge. This device uses the deflection of a flexible thin membrane known as the diaphragm. The pressure is indicated by using a needle which is moved with the help of pinion arrangements with the diaphragm. That means what? Due to membrane movement, membrane vibration, that from that the pressure is measured by using pinion arrangements. Capsule pressure gauge. In this type of pressure gauge. Two corrugated diaphragm are welded together at their periphery to form a capsule. This capsule is the main element in sensing the pressure. A hole is present in one of the diaphragm in the center, which lets the medium enter. The diaphragm expands or contracts upon the application of pressure. The capsule pressure gauge is used for calculating the pressure of gases and is utilized for calculating the pressure of substances with up to 600 millibar. Very low pressure we can measure it. Absolute pressure gauge. These are the instruments ideally used for measure the pressure independent of the natural fluctuation in atmospheric pressure. They are mainly used in scientific laboratories. Absolute altitude does not affect the absolute pressure gauge. Hence, they are used in aeronautics, heating, ventilation, and air conditioning system and distillation processes. That means altitude does not affect the absolute pressure gauge, so it's useful many areas. Differential pressure gauge. The difference between the pressure in two chambers separated by an elements that moves back and forth according to the changes in pressure is measured by the differential pressure gauge. A diaphragm present in the differential pressure gauge separates the media chamber from the vacuum chamber. Then, when the pressure increases, the diaphragm deforms into the vacuum chamber. The deformation and changes are converted into pressure values. Look at here. Here the pressure goes here, and so the diaphragm differential pressure due to difference in pressure up and down, we will measure that point through this pointer. Bellow pressure gauge. Bellow pressure gauge are the device used to measure low pressure applications. The bellow in the devices are made of thin-walled springly metal connected tubes that form a shape similar to an accordion. This is sealed in the free end of the gauge. Manometer pressure gauge. It's a device that is used to measure pressure on a fluid by balancing one column of fluid against the second column of fluid. Look at here. Here, the pipeline cross section is given due to fluid inside flow in the pipeline. Pressure created here. It shows a negative pressure because atmospheric pressure is more. It presses against because it is a negative pressure in the pipeline. The below figure depicts the simplest type of manometer pressure gauge that consists of a transparent tube in the form of U-tube partially filled with a manometric fluid like mercury. Here, suppose here pressure is more than atmospheric, that means this column will press here and this column come out. The difference between them gives the positive pressure. That means what is more than atmospheric pressure if the column goes here and come out. Here, advantage of manometer. It has a low cost. The manometer is suitable for low pressure applications. It is simple in construction, has better sensitivity, good accuracy. It has simple operation and construction. It does not have to be calibrated against any standard because directly you can use it. The pressure difference can be calculated from the first principle. The manometer is available for a large range of filling fluids of varying specific gravity. Disadvantages of manometers are it's a large in size and bulky. It is not easier to fit wherever you want. It needs leveling. You have to keep it in level position, then only you can measure correct reading. No fixed reference is available. In manometer, error is introduced due to condensation. It has no overrange protection. The manometer has a poor dynamic response. They have smaller operating range, which is on the order 1000 kilonewton per meter square. They are fragile and hence offer less portability because it's a glass tubes are there. It's fragile. The manometer fluid density depends on temperature. Hence, errors may result due to change in the temperature. It has slow response, which makes it suitable for measuring fluctuating pressures. It is unsuitable for fluctuating measures because quickly you cannot get it the difference in pressure in fluctuating medium. Piezometer pressure gauge. A piezometer is a type of manometer that is designed to calculate the medium pressure range of liquid. The piezometer pressure gauge is a simple glass tube that is opened at both ends. One end of the glass tube is connected to a pipeline where the pressure of a fluid is to be measured and the other end is open to the atmosphere. The tube is attached vertically such that the liquid in the pipe can rise into the tube. Because of pressure in the pipe, its liquid column rises up. That measurement is noted. From that, pressure is calculated. The pressure reading is indicated by the height of the fluid in the tube. Application of pressure gauge. Pressure gauge are used in various sectors in different applications. Totally, pressure gauge application is pressure gauges are used to measure the pressure of liquids, vapors, solids and gases. It is used for the inspection of air brakes on trucks and also inflation of tire pressures by using pressure gauge. Pressure gauges are used in chemical, petrochemical, sanitary, pharmaceuticals and process industries. Pressure gauges are used in HVAC, refrigeration, ventilation, food and beverage industries. They are also used in eliminating the potential leak paths. By measuring the pressure in particular area, we can identify leaks of the fluid from inflated tires and pipelines oil because of pressure difference due to leak. Boron tube pressure gauge. Look at here. This is a circular tube, like a 3/4 circular tubes. Is the due to pressure this inflate and that it goes. That is this expand like due to that expansion that pinion used in and that pointer moves regarding that expansion. Boron tube pressure gauge consists of an elastic tube that is bounded or welded on one end into a socket. The variation of pressure results in deflection in a tube. Deflection in tube measures the variation of the pressure due to medium is applied inside. Due to that medium's pressure, it deflects. Most likely every mechanical dial type pressure gauge you have ever seen basically depends on the principles of the boron tube. Here the boron tube pressure range is 0.6 to 7000 bar. These are classified as mechanical pressure measuring instruments and hence they operate without any application of electrical power. Advantage of boron tube is simple in construction. It is available in wide range. It has long life. Cost is low. Time tested application. Accuracy is high. Disadvantages: susceptibility to hysteresis, low spring gradient below 50 psi, susceptibility to shock and vibrations. That means it may affect, the pressure may affect due to shock and vibration. So far we discussed about pressure and its measurement and different pressure gauges. We have done. Please subscribe our YouTube channel.